It's funny. Sometimes the simplest questions hide the most profound secrets. Today, we're going to uncover one of them, and it's hidden in a place you've probably seen 1,000 times, a regular old math worksheet. Let's dive in. So, our source today is this page of math problems. Looks pretty familiar, right? Factor this, solve for x. It all seems so straightforward, maybe even a little routine. But lurking on this page is a single problem that stumped mathematicians for centuries. Because that's exactly what we're about to see. We're going to follow the rules, do everything we're supposed to, and run smack into a brick wall. A point where the math, as we know it, just seems to stop working. So what do you do then? To show you what I mean, let's just zero in on one of these problems, one that looks completely harmless, but is actually impossible to solve with the kinds of numbers you're used to. Here it is, from question 1, part I. Z squared plus 169 equals 0. Our mission, should we choose to accept it, is to find the value of z. Seems simple enough, doesn't it? Okay, let's give it a shot. So we subtract 169 from both sides, no problem there. That gives us z squared equals negative 169. The next logical step is to take the square root of both sides to find z. And we're stuck. We're left with the square root of a negative number, and that's a big problem. We've all heard this. It's one of the first hard and fast rules you learn in algebra. A positive number squared is positive. A negative number squared is times also positive. So there's no real number out there that when you multiply it by itself can possibly give you a negative result like negative 169. The problem seems completely unsolvable. But what if there was a way? What if we didn't actually have to stop here? Mathematicians decided, what if we just invent a new tool, a new kind of number, specifically designed to solve this exact problem? So let's meet the hero of our story. This is iota, represented by the letter I. Its definition is beautifully simple, but it is incredibly powerful. Iota is just a number with one special property. When you square it, you get negative 1. That's it. That's the whole idea. And this is what's so amazing. This single property, that squaring a number can result in negative 1, is the one key that unlocks an entire new dimension of mathematics. It's the one rule change that completely fixes our impossible problem. Okay, let's go back to our equation. We were stuck at z squared equals negative 169. But now, using our new tool, we can rewrite negative 169 as 169 times negative 1. Well, the square root of 169, that's easy, it's 13. And the square root of negative 1, by definition, that's iota. So z equals 13 times iota. Just like that, the impossible becomes possible. But iota isn't just some clever little trick for one specific problem. Oh no, it's a gateway. Once you accept that it exists, you can start to tackle much, much more complex challenges. Let's see how this thing builds. So on the left, you've got the kinds of problems we started with, where iota shows up as the solution at the end. But now, look at the image on the right, from question 4 on the very same worksheet. Here, the problems themselves are built using iota. The whole game has changed. And this is a really crucial distinction. Iota wasn't just a quick fix, like a patch to fix a bug in a video game. It actually revealed that our number system was incomplete. Adding iota and the complex numbers it creates makes the entire system of math more consistent and way more powerful. Look closely at this example right here. We're being asked to solve two equations with two unknown variables, z and omega. But now, iota isn't the answer we're looking for. It's a fundamental part of the question itself. It's right there in the coefficient, that 1 minus iota part, showing how deeply integrated it becomes in higher math. The difference is really night and day. Without iota, a simple-looking equation hits a dead end. But with iota, we now have the tools to build and solve entire systems of equations. We've gone from being stopped by a problem to building brand new mathematical structures with it. So this new number, iota, lets us solve more math problems. That's great for a math class, but why does it matter to the rest of us? Well, this is where it gets really interesting. This number is often called imaginary, but its impact on our world is very, very real. This quote from the mathematician Jacques Hadamard just captures the idea perfectly. What he's saying is that to solve very real problems about the world we live in, sometimes we have to take a detour, a shortcut, through this world of complex numbers, the world that iota unlocked for us. And here's the proof. Electrical engineering, signal processing, quantum mechanics, All of these fields are built on this kind of math. Why? Because complex numbers are the perfect tool for describing anything that rotates or oscillates. Think about waves, signals, or quantum states. Iota gives us a way to handle both a magnitude and a direction, or a phase, all in one elegant package. The math on this worksheet is literally the language used to describe our reality. So, the huge takeaway here is this. The name imaginary number is maybe one of the worst misnomers in all of math. This tool, iota, which was invented just to solve an abstract puzzle, turned out to be a key for understanding the physical universe. And that leaves us with a final thought, doesn't it? We started with an impossible problem on a worksheet, and we ended up at the foundations of quantum mechanics. That really makes you wonder if a concept we label imaginary is so essential to describing reality, maybe we need to rethink what we consider real in the first place.